I'm really nervous. Go easy on me. Before I start, since nobody's done it yet, give a big round of applause to Mike and the rest of the Mountain West crew. And also to the fine folks at Confreaks that are recording all this. So. I gave my mom the URL, so hi, Mom. Hi, Mom. So I'm going to talk about Ruby, batteries included. Ruby can standard library, and so can you. So how many gems does it take to build your application? I know Fletcher down here, how many gems does Blue Box use on a regular basis?
We'll say dozens.
Does anybody know like how many gems you got in your gem file? You open up your gem file and it's just pages and pages, Aja?
17.
Oh, that's a lot of gems.
Like in the gem file or just total?
Well, so there's, you can look in the gem file that you explicitly depend on, and then there's the gems that they depend on, and then just a big chain of dependencies, right? So this is a quick, dirty way to look in your gem file. That's what our app at Yardstick does, 135 gems. There's like 6 for rescue, right? There's rescue namespace, retry, the scheduler, and there's unique jobs and all this fun stuff. So do we really need 135 gems? Yeah, you got to talk to a database, and maybe you really don't like ERB, but okay, we need to do some CoffeeScript. But there's probably a few that we can clean out of those, and the standard library can actually do a pretty good job of getting you there. Maybe you have to write a little bit more code, but hey, we're all programmers, so let's write some code. So we're going to look at the standard library, and it's actually broken into 2 sections. There's the core, which is stuff like enumerable, string, things like that are kind of built in, part of the language. And then there's the standard library, which is stuff that is there, but it's not, you have to require it, and you don't have to use it, but it's just kind of there, packaged as part of the language distribution. So we'll use these handy images in the bottom right corners. There's the core, which is a fantastic movie, and that's Ghostbusters. They're in the library. So a quick, dirty way to figure out how many classes, I'm not sure how accurate that is, but you know what? 552, let's get going. We got a lot to cover. We're not going to do all of them. We're going to go through some basic things that you should probably be using on a day-to-day basis, maybe. Performance things to measure performance and help improve performance, and then we'll go beyond that into, the beyond section. Not all this works in 1.8, so don't be like Brian. Just use Ruby 2.0. Where's Matt's? He's happy about Ruby 2.0, so we should all be. Matt's uses Ruby 2.0, so we should use Ruby 2.0, right? So we'll start with the basics. Where's Ward? How many has he used? All right, so set. The set data type. Everybody's probably used an array and just called unique on it, shoveled some values in, and then, we don't want unique values. Yeah, how about we use a set? This comes with Ruby. It's free. You shovel things in like an array. You can iterate over it, but of course it's a set, so it enforces unique value constraints. So if you put something in twice, it's not going to go in twice. So you require set. We can make a new set, and see I've tried to put 1 in 4 times, but of course it only went in once. Another advantage with set is that inclusion checks, like if you do .include on it, it's very, very quick, whereas with an array, you've got to iterate through the whole thing. Has anybody used set? I've used it a few times. Yeah, good stuff.
You should use it anytime you're doing .include.
Yeah, so the other thing with this is that iteration order isn't, you can't rely on it. I think in Ruby 1.9 and above, it will kind of iterate in the same order that you put things into because 1.9 preserves hash insertion order, but I wouldn't count on it. Speaking of iteration, enumerable. Everybody uses enumerable. I'm sure some of you right now are typing .each on something. Right? So enumerable gives you all of those .each, .map, each with index, reduce, collect, blah, blah, blah. They give you all of those things. Fun part is you can implement this, or you can use the enumerable module yourself, we've got a thing here, and it doesn't do anything terribly exciting. Imagine that it would change files. But basically, we include enumerable, some other stuff happens. We shovel things into our files array, and then I define the each method, where I just iterate over the files and I yield some stuff. We can then do some other things with it, where we shovel some files in, we call each with index. Wait a minute, and we call map, and we call reduce. But I didn't define any of those methods. I just defined the each method and included the enumerable module, because all enumerable needs is that each method, and it implements all the other ones in terms of each. So this all unsurprisingly works. I just merged a pull request, or I just reviewed a pull request in our code base at Yardstick where a guy included enumerable because he needed each with index. And we get all this stuff for free. And well, yeah, you could implement each with index, but screw it, enumerable gives it to you for free. To go along with enumerable, we can do enumerator. So in Ruby 2, we got the lazy enumeration stuff. You can implement the lazy stuff in Ruby 1.8.7 with enumerator, like that. In fact, we have a file called lazy.rb in our app because it's 1.8.7 and Rails 2.3. So with enumerator, you can build your own enumerators on the fly. So you can also, it's a little far over, but you can also kind of, doing this works the same way. You can build an enumerator from something that is enumerable, and it'll work the same way. The other fun stuff is we're going to build all the natural numbers, so we're going to have a new enumerator, and that y is the yielder, so you can shovel things into that. We're going to use the naturals and shovel out just the odds. We're going to do a really naive prime check, and we're going to get all the primes. And then we can take the primes because the enumerator is just an enumerable. So I just take the first 10 primes, and I didn't need a big list of primes. It just generated those on the fly. So if you want to do something lazy, like you got a big array of stuff, maybe don't use .map and .this and .that, because it'll actually build an array each time. You can do it lazily. And again, in Ruby 2.0, you can just do .lazy, but if you're in the dark ages like I am, you can use enumerator. SimpleDelegator. Everybody's read 7,000 blog posts about DCI, right? You have the data context interaction where things don't have the methods you want them to until some point in time when they actually need to do stuff. So the problems with DCI are that, we use extend, and then we blow out the method cache, and everything becomes slow. SimpleDelegator can help you with that. You require delegate, because it's in the standard library as opposed to the core. And we're just going to inherit from it. I made a fancy string, and it just has another method on it that checks if it is in fact fancy. So we make a fancy string with the string fancy, and of course it responds to fancy question mark. And it also responds to length because it just simply delegates all of the other methods down to the underlying object. So you can treat it like a string, but then it also has this other method or whatever other methods on top of it. SimpleDelegator's friend is Forwardable. This goes the opposite way. So we can require Forwardable, and I'm going to use a struct here. And it's going to take in a string, and we're going to extend Forwardable, and then you get defDelegator and defDelegators. So defDelegator is just going to delegate a single method while renaming it. So we can call fancy length, and it'll be the same as length. And the other one down here, we're going to delegate a number of methods without renaming them. So we can make a new fancy string again. Include is going to work because we delegated it. And fancy length is going to work, but byte size is not going to work because we didn't explicitly delegate it. So it hides things that you don't want. Has anybody used SimpleDelegator or Forwardable in their stuff? I find it pretty useful. You can, if you want like a simple, something like Draper, like just a view kind of model thing that you want to wrap, you can throw something together really quick with SimpleDelegator to just add some sugar on top of your active record models or something like that. So that's the end of the basic stuff. These are all things that I think you can use on a regular basis. Like I say, everybody uses Enumerable, set is pretty popular, and Delegate and Forwardable are also pretty solid. So we'll look at the performance stuff. This is the kind of stuff you can do if you build your own web framework. That's DHH's car. So benchmark. Everybody loves benchmarking code, right? This package is probably the starter of more arguments on Hacker News than Bitcoin. So this is in the standard library we can get from the Ghostbusters down there. We're going to require the benchmark package, and we can do just a simple measure. That'll just measure that block of code. And I put out the results, and it comes out as a string, but it's actually a results object, and you can call, there's 4 methods to get the CPU time and the system time and the user time, and the important one is the one on the end, which is your wall clock time. Again, it defaults to just a string, which is, or it formats itself to a string, which is the same format as the Unix time command. We can also benchmark separate blocks of code in a report format. So if you want to say, well, what does this do compared to this, we can benchmark the 2 blocks. So, a standard little 3 different ways to do a loop. Sometimes that's, that just outputs 3 lines like the previous line up there. That's kind of boring. So we're actually going to include some labels, and the 10 is just the column width for your labels. And even if you want to go one step further, you probably should be doing a warm-up, which just runs the code and then runs it again. The warm-up is just for, to make sure the CPU cache is happy, make sure everything kind of settles down. So, if you're looking for code, you can do your thread profiling stuff. You can use New Relic, or you can just bust out benchmark. If you got something really simple and straightforward, throw benchmark at it. Think about how you're benchmarking code. Maybe read some statistics books, and then use the double BM method there to do a warm-up with a report, and everything looks beautiful. So you found some method. You found your Fibonacci method is slow because your app has a Fibonacci method. There's users log in, users log out, lame Fibonacci. That's every app. So maybe you wrote a standard, tail recursive Fibonacci method, but Ruby on its own, it has tail recursion support to optimize this basically into a loop, but it doesn't do it by default. So if you just run this, it's going to explode, the stack's going to die, and you go home sad. But this guy on this blog post, this isn't stuff I found out on my own, this guy did it. We can go to the Ruby VM instruction sequence, and this is 1.9 and up. So we can set up some compile options to tell it to do tail call optimization. Holy shit. And the trace instruction also needs to be false. So there's 2 ways we can actually make use of this. You can just load a file after this, load some .rb name, or you can just eval the code like that. And then you have the fib and ACC method in your scope here. So this method it's exactly the same as what was on the previous slide. Haven't done anything with it. Now it runs. That runs almost instantly on my laptop, and you get a digit, big long number. So, you're probably not going to do this that often, but if you have something that is naturally tail recursive, Ruby can do it. We can do it, and you don't blow up your stack. So you optimized your Ruby, but it's still not fast enough, and we need to go out to a C library. Okay, so there's gems that glue into the C library. You can write a C extension. There's Ruby inline and whatnot. But if you just want to call out to a single method in some dynamic library, we can use Fiddle. This is sort of like FFI. I guess it basically is FFI. It's just not FFI. This comes with Ruby as well. We can require Fiddle, and I'm just going to include Fiddle so I can make the code shorter and make the font bigger. The DL module comes with it, so you dynamically open some thing, and because I'm on a Mac, I have to do the dy lib On Linux, you're going to do a .so file. So we get a lib, and this is just the math library. We can get a hold of the function, which is, in this case, a square root function. We set up the arguments. We tell it it's a type double, so of course that comes from the Fiddle namespace. And it returns a double, and we make a new Fiddle function out of it, and then we can call it. I didn't have to do a whole lot there. I called out to a C function, just like that. So I mean, if you need to call out to something like this, you don't, really think about whether or not you need to pull in some big gem to do it, or whether or not you can just call out to a single function. Maybe you hack up a little shared library that does a lot of the work in C for you, and then that gives you one function to call into, and Fiddle can get you there. So we've got our CPU down, everything's running fast, but maybe we're kind of bloating on memory a little bit, and maybe we're pulling in some things, and we want to kind of keep them around, but if they get garbage collected, it's not big of a deal. So we can use WeakRef. With WeakRef, you probably want to be on Ruby 2. There was a lot of improvements done to it. Specifically, if you're on like the Ruby Racer, if you're using the Ruby Racer for something, they make a point about saying use Ruby 2 because the WeakRef gem or the WeakRef implementation is a lot better. So WeakRef will wrap something, whatever you give it, in a weak reference, meaning that it can be garbage collected. So you can use it and do your stuff with it, but when the garbage collector runs, it'll be a candidate for collection, and it might go away. So we're just going to require WeakRef, and I'm going to read some HTML from some big page and wrap it in a WeakRef, and I can put it out, and it looks like a string as far as it's concerned, but then I can also check if it's alive, meaning the garbage collector hasn't collected it yet. So we can run the GC, and now we check that it's alive and it's dead now. So it's gone, you can't do anything with it. So I mean, you could take this and wrap it in some sort of a cache, and if it's just an in-memory cache and you want things to be collected, sort of like an in-process memcache or something, this will let things get collected by the garbage collector, so you're not bloating all that memory if you don't care that much. So that's it for performance stuff. Does any of that sound interesting? Everybody's used Benchmark, right? Everybody. Don't even lie. You were posting on Hacker News yesterday. So beyond. It's a platypus. So we're going to build an application, and we need random numbers. Well, you know what? Ruby comes with SecureRandom, and it's secure. It's not math random where you give it a seed and you have a nice predictable chain of things. It's SecureRandom. So don't be going and building out an array of A to Z and then sort by rand and sample from. Don't do that. Just use SecureRandom. You can get base 64 values. You can get hex values. You can get random bytes. You can get a random number, a float, and then you can get a random number, an int. I really don't like that because it'll return a float or an int depending on the argument, whatever. Oh, and you can also get UUIDs. The only thing special about the UUIDs is the version number. Everything else in it is random. So cool, we got our app. We're building. We got secure random numbers. But somebody came back from a conference and saw 4 talks about service-oriented architecture. So we got to put this in. We got to make a service. We got to make a random number service. But we're not going to do HTTP. We're going to just do TCP because, hey, we want it to be fast, and we don't even want to load Sinatra. So we're going to do GServer. Does this ring a bell for anybody? Has anybody used GServer? Yeah, that's expected, but okay. GServer gives you a threaded TCP server. Threaded. Okay, it's thread safe, it's happy. It takes care of all of the connection and disconnection and all of that junk for you. So all you have to do, inherit from GServer and define serve, which takes an IO method, an IO object. That's it. I'm going to read 4 characters from it and check the command, and if we get hex, I'm going to send back some hex, and if I get UUID, I'm going to send back some UUID. So we're going to start up this, or make a server on port 10101. start it, and just join on the thread to block, wait for it. So you can now telnet to localhost 10101, type in hex, and it'll spit you back a hex value, and then close the connection. Or you can do UID, and it'll give you UID. If you give it something else, it'll just close the connection, and you're done. So cool, we have our service-oriented architecture, we're done, right? Well, no, somebody else came back from another meetup conference user group, Hackfest, and they were doing Rust. They were hanging out with Steve Klabnik. So we need to shell out now, because they wrote a random number generating thing in Rust, but we can't load Rust from within Ruby, so we got to shell out to it. So we're going to use kernel spawn. Spawn is like system plus exec, fork exec on steroids. This method here, if we're going with great names for methods, captures I/O of a command. The spawn method in there takes a command and some other arguments, which include where standard out goes, where standard error goes, standard in, environment variables, UMask, directory to exec in. Like it has a whole bunch of stuff, and the docs for this method are fantastic. It just gives you like a big blob of this is what we accept. So pretty much anything you'd want to do with execing some external process, you can do it with spawn. And it just gives you back a PID, so we're going to pass in a pipe and wait on the PID and blah, blah, blah. So we wrote our Rust randomizer program, and we're going to shell out to that and capture the output. I love spawn. Spawn is awesome. If you're doing a lot of shelling out, like the GitHub guys where they had to use POSIX spawn, I'm not sure of the exact implementation details of underneath how this happens. So if you're doing a lot of shelling out like they were, you might need POSIX spawn. But now we've also, somebody read an academic paper, and that always works out well. And we figured out a new way to generate random stuff based on already securely random stuff. So we need some input from the user, actually, and we need to pipe that down to this thing. So we're going to actually take some input and use Shellwords. And we already saw Shellwords, was it yesterday? Earlier today? I can't remember. So Shellwords, normally you're going to run system or something like this, and it'll take an argument, comma, another argument, comma, another argument, and that'll get passed down, and the operating system will take care of that so that you don't have to worry about escaping things, and you don't have to worry about users sending rm-rf to your system. Sometimes, though, you need to actually just send a string down because you want the shell expansion to happen. You want, like, star.rb to actually go down to the shell and expand on all the Ruby objects, or Ruby files. So, well, how do you then cram user input into that string so it's not going to blow up? Well, you do it with Shellwords. So we can require Shellwords. We can have some pattern from the user, and that's, I don't want that run on my system. But I can run this, assuming we can pass this into our randomizer thing. It's going to pass that as the first argument, and then for some reason it needs a list of all the dev devices. So we can do pattern.shell escape, and that will go in and be all happy. It's not going to actually run that. And the shell expansion on dev/star works. So if we try to do it like this, assuming the capture command a few slides ago worked like system, this wouldn't work because it would get, instead of getting a big long list of all of the devices on your machine, it would get /dev/star, and that's not an actual file. So cool. We got our TCP server that's serving random numbers written by a Rust program that now takes user input. Well, I guess we better audit this, right? We need to store these random numbers to really make sure that we're not giving random numbers that we've seen before, right? It's the obvious next step. So for that, we're going to use PStore. We don't need no Postgres or Mongo or ROFL-scale, Node.js, dev null database. We can use PStore. That was a lot of buzzwords in there. So PStore comes with it's in the standard library. And it uses Marshall to serialize stuff to disk. Oh, the kicker is it's thread safe. It can be ultra safe, which protects you against I/O problems. Like it'll write the file and then do an atomic move as opposed to just overwriting the file and maybe you ran out of disk space and now your whole thing is corrupt. So we're going to make it thread safe and ultra safe. And oh, it has transactions. And it uses Marshall, so we can just store stuff in it and it goes to disk. So we're going to store our app name and random number. And we're going to read out the random number and it'll give us whatever that thing returned. And we can also abort a transaction so that change won't take effect or an exception gets raised. And then now the thing shows the exact what it was before. So you don't, if you have like some little app, you don't necessarily need to dump in a database. You have PStore. There's also like DBM and GDBM and like 4 other DBMs depending on which way you compiled Ruby and what libraries you had available. PStore is kind of the Ruby-friendly version where it should work everywhere. It's thread safe, transactions, and you use Marshall so you can store pretty much anything in it. And of course, I haven't even talked about testing. We've been writing this app, and we haven't even tested the thing. So you've built your app with no external dependencies, but now this douchebag's gonna, make you install 6 things to just run the test. You clone the gem, rake test, and it's like, oh, you need to bundle install and install half the world. Never fear, MiniTest is here. This comes with Ruby. It has MiniTest, or standard test unit syntax, and it's got RSpec syntax, and it's got mocks. Mocks aren't, you have to manually verify them. There might be a way to do that a nicer way. I don't know. No, I'm getting head shakes. So this comes with Ruby. And using something like MiniTest, especially if you have like a gem that you want people to hack on, if they have to install a bunch of things, okay, it's easy with bundler and Ruby gems and blah, 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 but if they can just clone the code and run rake test and they see a bunch of green dots fly by, that's awesome. If they see, oh, I'm sorry, you need to install RSpec and Mocha and WebMock and blah, blah, blah. Cool, I like RSpec, I like Mocha, I like WebMock, they have their places. But if you're building a small gem, maybe just think about using MiniTest. It's there, it's free. You don't have to do anything. So that's the beyond section with our random number generating, service-oriented, NoSQL store, audited, tested application. Other fun things. We've got option parsers. There's 2 option parsing libraries in the standard library, 2 of them. And another gem just went up the other day. And not to criticize the author or the project or the code, but we got 2 of them, and they're pretty good. We've got WebBrick, HTTP server. We have an RSS package, guys. We can build Google Reader, okay? At the Hackfest, build Google Reader with the standard library. You can do it, come on. We've got DRB, so we can have a distributed object system. You can iterate over the file system. You can parse Ruby files and get like an AST out of it. For doing thread stuff, you can use threads wait to wait on a list of threads and then get a callback when one finishes, as opposed to just mapping over your array of threads and calling join and whatnot. Of course, with queue and size queue, those are, I think, the only thread-safe data structures in the language. So you can shovel things in, pop things out. With monitor mixin, you get a synchronize method that takes a block, so you can make your own data structures thread-safe. Of course, there's the net packages, so we can talk email, we can talk FTP, and we can talk in some weird dialect HTTP. It's not, if you follow one specific incantation, it works not too bad. So, when you're building your app or your gem, maybe just, we have a big ecosystem of gems. We got Ruby gems, we got GitHub, and there's a ton of code out there. but maybe you don't need to use all of it. Maybe, you know, if you have something that you can write your little 20-line class and it does 90% of the job, maybe do that, and then we don't have to depend on somebody else's gem, and we don't have to install this thing in CI server. It takes like 10 minutes to install all those gems on Travis. 10 minutes. So, yeah, don't cry when you try to install all your gems, and just think about your code. Maybe the standard library already has something that can take care of business for you. So thanks. That's me. Thanks to Yardstick for sending me here. My boss is over there. And I blog and tweet and write code. So.